Hello, and welcome everybody to the third episode of Do Your Own Research, our new Defiant IC3 sessions where we're trying to dive into all different areas of the crypto industry and how research and development, academia plays a role in all of that. Today joined by another very esteemed and very exciting panel of experts who are sort of diving into the cutting edges of crypto, digital economy, academia, all that sort of stuff. So joined today by Harjasleen Malvai of University of Illinois Champaign, Andrew Miller of Flashbots and Psycho Money, and Joe Andrews of Aztec Network. Thank you very much for being here. So today, I'd love to get the ball rolling on a question that's sort of pretty open, but I think it'll sort of serve as a good entree to the conversation. If each of you could just give us a brief intro on what you're doing now, and if you could tell us why privacy in the digital age is important. Harjasleen, if you want to get the ball rolling.
Okay. I guess one of the big problems that I think about in my research is identity and identity solutions, and basically how you can do those for decentralized applications or even centralized applications, which often requires working with tools such as zero knowledge proofs or multi-party computation, even TEs. That's a trusted execution environment for people who are new to the space. And I mean, in this particular theme of identity, I mean, obviously privacy is important. People don't want to give their data to just anybody. And if anything, if you do share your data, you want to probably get paid for it. So it just shouldn't be freely available. I think that's a debate that people have had for quite a while now, right? I mean, you don't want to get doxxed, you don't want to get stalked. And of course, those are just the most extreme examples. You even have things like you don't want to get front run by people who just have more power and money than you. So yeah, that's what I would say.
Joe or Andrew, whoever wants to go first.
Yeah, I can take it. I mean, I'd echo a lot of that, and I think so. Yeah, at Aztec, we're kind of trying to solve some of those issues by building kind of an execution environment that has kind of privacy as a core primitive. We're building that as an L2 on Ethereum, just trying to add kind of programmable privacy to everything we do. I think if you think about why this needs to exist, you just need to look at the real world and kind of see the inherent levels of privacy that are all around us, and then you kind of compare and contrast that to what we've created in Web3 as it stands today, and there's a huge delta. And so just putting all this information onto public blockchains without getting paid, as Harjasleen said, is kind of something that I think needs to change. And we just have to look at kind of Web2 to see how much of our lives is encrypted or private on Web2. And I think before we start pushing this technology for kind of mass adoption, we need to fix some of the inherent privacy flaws. So yeah, that's what we've been working on, and very happy to be here. So thanks for having us.
Interesting. Andrew, the floor is yours.
Yeah, I agree with all of those. I've done well with the Zcash Foundation for a number of years now, and kind of come from the privacy activist viewpoint that's concerned with long-term user privacy, among other goals. But while I've been on leave for a while working with Flashbots and with Cycles, I'm pretty interested in a proving ground for privacy technology that comes from these other motivations for it. So in the case of Flashbots, it's pre-trade and post-trade and failed bid privacy for various kinds of auctions. So privacy needed to achieve some economic goal like that. Similarly, at Cycles, it's about privacy for business data when what we're trying to do is inter-community clearing. So I've been especially looking at what kinds of technology are well suited to that. Something that I've also been really focused on for the last couple of years is specifically trusted hardware. So that's the most interesting tool that I work on. So yeah, I love to talk about the distinctions between that and some alternative approaches like zero knowledge proofs, which yeah, I've worked on in the past too.
Yeah, no, we'll definitely dive into that. But first, I want to circle back to you, Joe, and ask you, because I think this is a question that a lot of people have when it comes to, yeah, like you said, the just general internet of today and how Web3 is making huge strides in the privacy sector. And as somebody who's leading a privacy first layer 2, you've obviously seen firsthand the state of privacy on chain. So how would you consider, if you could sort of grade it from 1 to 10, what the state of privacy is on chain? And if it's even like, if there's a sort of ideal that you guys are aiming towards and building?
Yeah, it's a great question. Yeah, I'm pretty bearish, so probably like a 1, 1 out of 10 maybe. I think that there's a lot of hype and mismarketing on the current state of privacy on chain. I think if we look at what's working, the things we have on Ethereum, at least today, that's working. I'm going to exclude alt ones for now. We can go back to those in a second. But the things that's working on Ethereum today is at best app-specific privacy. So someone may have made a contract that can shield some inputs or maybe give a small amount of privacy when you're using that specific app. So a payments app is a good example of that. There's a few kind of new payments apps, Railgun, ZK Bob, some examples, but at best, like they give you kind of in-flight privacy when you're using that app. It's still completely public that you put money into that on Ethereum and kind of that the app exists, how much money's in it, and that you've used the app. So it's a pretty weak form of privacy. In terms of where I think we can get to, like how do we get to a 10? Yeah, we think about it in kind of like a gradated scale. And really it's actually not that useful to be at a 10 in all applications, because there's like the kind of analogy of a tree falling in a forest, and does anyone care or does anyone know? I think if everything was completely private, it would actually be a pretty hard world to interact with, and we have to share some information to interact with fellow humans. So I think like we think about it in terms of like a gradated scale, and that scale kind of incorporates user privacy, as we talked about earlier, kind of like who my identity is and things about my identity, maybe balance privacy, kind of what I'm transacting, kind of in the Flashbots use case. Then you can get right to the end of the scale where you can actually hide the functions that I'm executing, and that's maybe less useful, but it's still pretty cool. So depending on your application, I think the real goal is to give developers that choice and say, what do they need to make their application as private as possible for their use case, and not make it kind of opt-in. So they should kind of by default have a lot of privacy, and then they can peel back layers of transparency as needed for their application. And I think that's how we get to the higher end of the spectrum. If it's opt-in, like Ethereum today, you're stuck at these kind of cases where at best you can get a single shot privacy for one app because someone's opting in to use that, and it's not kind of users revealing their data when asked to.
Andrew, would you agree with the grade 1? And is there any sort of, I guess, particular area where you do think that there might be a higher grade or somewhere where you are, maybe it's, I mean, it's not hard to be slightly more bullish than 1, but yeah, more bullish than 1?
Yeah, I mean, it's not uniformly distributed. I think giving a 1's appropriate for, say, the crypto ecosystem as a whole. And yeah, of course, if you look at just how Ethereum's used, that's not exhibiting it. On the other hand, there's a lot of really successful privacy projects. So of course, Aztec is one. I think Zcash is true too. You know, within these ecosystems, there's, you know, some usage of privacy, but I absolutely think that programmability, the ability to do fine-grained disclosure and explore all of those spectrums of you know, what context you want to keep information contained within, disclosing to some but not everyone, disclosing based on conditionals and rules, all sorts of things like that. I think that's the really interesting, rich design space. So you know, any project that's exploring that, and there are a bunch of those, I think are doing a great job. And the hope is just that enough of these land, and you know, if they're platforms, then they bring privacy to killer apps on them, or if it's individual apps, then at least they set a good example template that others can follow. So yeah, one overall right now, but lots to be optimistic about.
Would you like to see more pressure from developers or from users when it comes to the whole privacy conversation?
That's such a great point. I mean, one of the things I've been thinking about a lot is that I've seen this throughout the research career and in industry, but you know, things get driven by momentum with user feedback, and you don't really get that steering you towards security. Just in terms of getting like elicited preferences from users that are going to rank that as a priority or pay for it in some way. So it has to come from somewhere. I think that it often does come from developers and researchers too. So maybe that's a connection to academia. I think that there's a general sense around the technically informed people that this is the right way to do things, and so there's a lot of support for that. But it's better when it comes from users. I think if it doesn't end up coming from a combination of developers and users, then it'll have to come from regulators, and that's the worst case scenario. So I think it's kind of you know, it's an important topic to discuss this way because we may be at the precipice of either successful self-regulation where we get to set it under the terms that we want, but do a good job for society, versus you know, not finish that work even, you know, among those who are trying real hard at it. And so yeah, I hope it comes from some combination of those.
Yeah, I agree. I sometimes do think that the privacy conversation is sometimes just too technical, and people end up believing that privacy becomes this sort of unattainable goal just because there's also like a pervasive idea that privacy online is something impossible to achieve. And I think it would be interesting, Harjasleen, if you could give us the sort of background on how academia is looking at this sort of stuff, what your research is telling you, and yeah, are researchers as bearish as we are to the whole privacy in the internet age?
Well, okay, let's break this down, right? Well, internet age, maybe let's talk about Web3 age, and limit it to that. What I personally think is that blockchains are both overutilized and underutilized at the same time, and that partially causes some of these privacy issues, and also in a sense like adoption issues for blockchains themselves. In particular, I think one thing I would like to introduce to this conversation, that I think academics have been talking about for a while, but maybe the blockchain ecosystem hasn't been talking about as much. Maybe one project I've seen that is talking about this is WorldCoin, and what I'm talking about is the idea of transparency for like basically centralized applications, which I think is a nice middle ground. Some people might strongly disagree with this and have very strong opinions about it, but I personally think that that's a way to basically, for example, not use blockchains for applications that are privacy critical, but at the same time not fully rely on some sort of centralized party to like be serving things correctly. So you rely on a centralized party that is already regulated and required to maintain user privacy. So for example, there's GDPR and California privacy laws that govern things like encrypted chat, for instance, right? And one of the problems in encrypted chat, similar to a problem in regular Web 2, is how do you get the correct private key for correct public key, sorry, for a person. And you already have encrypted chat systems that serve these public keys to users, right? So you could use these sort of transparency infrastructures to then hold these companies accountable for serving the correct thing, not serving incorrect things, which is exactly what blockchain was meant to do. But at the same time, leveraging the privacy that is already provided by existing Web 2 or Web 2 adjacent infrastructure, right? So I think that's one thing from academia that really kind of hasn't transferred over. And in that sense, blockchains are really underutilized in decentralizing-ish centralized architecture. But also there are things that are getting decentralized. There's a paper from I think 2014 called Ethics, which is basically doing a similar thing for public keys, but like straight up on chain. And so now everybody can see every time I change my phone number or every time I change my phone and things like that, which is not desirable, right? So I think making strong models for like when actual on-chain is required and when it's useful to build an application fully decentralized versus when it's useful to potentially have some sort of centralized model and use the blockchain for accountability, I think is one thing that maybe needs to float out of academia.
How do you propose, if you have a proposition, it doesn't have to be anything really concrete, but to sort of bridge that gap? I mean, it's funny because we talk about bridges in the crypto space a lot, but yeah, if we can bring stuff from one side to the other, especially to fill in those gaps that you're seeing. If you have any ideas of what us as Web3 like crypto native users can not only be using but also be asking more of, and how researchers can also be looking towards the crypto space for different ways to also implement those sort of solutions or research those sort of solutions.
I think to some extent it's also just a scientific communication issue where like there aren't necessarily, I mean, I guess something like this is very useful for telling people that some solutions like this might exist, right? I don't think a lot of people even know that things like this exist. If most of where we're talking about this is at academic conferences and in advisor meetings and things like that, like that's not something that is getting widely heard about. I think that's changing a little bit with, for example, I interned at WhatsApp working on actually this exact key transparency problem, and some of the cryptographers internal to WhatsApp really pushed for getting this type of transparency deployed. So if I think it's a combination of making users aware of things, making other developers aware of things who are Web3 native developers who are maybe working more on, straight up smart contracts on Ethereum, things like that. And then to some extent, academics / cryptographers who've switched over to other types of work, pushing for deployment of things that academic cryptographers have already sort of concluded, yeah, this is the right thing to do. And obviously everybody should be doing it. I mean, I'm not going to go deploy it right now because I have other papers to write, but obviously everybody should be doing it. So it kind of, I think, goes in, takes a backseat in academia a little bit.
How do you view it, Andrew? Because you've also have a lot of background in academia. You've been in the space for, if I'm not mistaken, like 2011 or 2012. So I think if you could share a little bit more on how, for example, going back to what you said in the beginning of this conversation about how the hardware space has evolved a lot versus, for example, ZK technology. And if you could share a little bit of that sort of timeline that you've seen even from before these types of technologies have come to be, and how that sort of laid the groundwork for what's being built out now.
I mean, there's, I guess, two cool threads to go there, but the one I wanted to respond to is more along the lines of how bridging between Web3 or blockchain and industry has gone. I made it a personal point to care about the industry and academia interaction since back then. At the time, one of the things to do was just to write a good survey paper that included all the discussions on Bitcoin talk forums, where that was really when the open source Web3 people really started contributing up to topics, innovative research and topics that normally had the domain of only academia. I've absolutely noticed over the time, and with IC3, one of the main goals has been to stay very closely involved with industry, try to listen to their problems, do the groundwork of translating and packaging things to industry so that they're more easily used. Focus on open source software and such. What I have now as a current thought is a couple of things. Well, also one for me personally, I think I've decided that a way that I want to do this is by getting even further within industry. So that's how I've worked for the past couple of years. I think broadly an insight about, I've noticed academia does two things kind of in the opposite direction, time-wise, different than industry. One is going really slow and one is going really fast. So going really slow in the sense of bringing, say, validation or prioritizing security and being very careful and considering all things in a way. Those are some unique attributes of the academic approach to things. But academia is also often a huge innovation driver. And I think that one of the ways that is possible is because when you do validation and research, you're essentially testing out an idea by providing some sort of validation for it. When you do things in industry, of course, you release them on market and you get market validation, and that's great, but it's not even that it's not controlled, because it's really realistic. If it really works in market, it had to do everything well, but it has less power and therefore can be harder to do. You have to get your marketing and your developer relations and all of your things right to succeed in the market. Whereas with lower resources, lower authority, if you just have an idea, you might go through some alternate validation, and that's good enough to propel it as research innovation. I don't know where that leaves us. That's just on my mind.
Would you like to see? Yeah, go ahead. Sorry.
I was just going to say, I think like the exciting point is like where we are right now, because I think for like I'm not an academic, so take this with a pinch of salt. But I think sometimes we've been kind of stuck with like proposing new ways of doing things to industry, and that requires like a paradigm shift for it to be adopted. And those are the harder sells. But there's been so many great advancements in kind of the underlying cryptography, like the proving systems, whether it's the hardware in TEs through to like the proving systems in ZKPs, that I think we can kind of meet industry where they already are. So if you're using an RSA signature, or you're using kind of something that has existed on the internet for a while, we can now prove that kind of signature scheme, or we can use that in a TE. And I think that's a big unlock, because before we were kind of like proposing a paradigm shift, which is like, hey, adopt this new tech and you'll get all these benefits, but the barrier to adoption was huge. And now it's just strictly additive. Like we're seeing a lot of use cases in the DYOR ecosystem around this already, with kind of proof of passport or TLS notary, those sorts of cases where we're meeting the internet where it already is, rather than trying to kind of change it. So I think that's like we're at the precipice of maybe a big unlock in terms of adoption in the industry.
And at Aztec, do you often look towards the sort of research and develop, or where does the research and develop side of things affect or influence the ways that you are building, both your underlying technology, how you're approaching maybe other developers in the space, the conversations that you're having with other protocols and other builders?
Yeah, it's a good question. And then like Aztec wouldn't be possible without kind of a lot of prior art going back kind of 20, 25 years. But we have made a lot of advancements, or I'd say Zach and our kind of crypto team, Ariel as well, have kind of pushed some of the state of the art in terms of what proving systems can do. So in 2019, like the Plonk paper was published, which was kind of new research. Wasn't the first universal proving system, but it was a kind of a much more efficient universal ZKP. And so universal just means it doesn't need a trusted setup for every program. And so we've had to kind of, I guess, balance on a bit of a tightrope, investing in research in order to kind of push the cutting edge, and also shipping products to kind of stay relevant to the market. And yeah, we're kind of 3 or 4 proving systems later, and so sometimes we haven't got that balance quite right, but we're pretty confident that the latest kind of proving system does everything we need to ship kind of mainstream products. So I think it's always going to be a bit of a balancing act as the underlying tech advances, but at some point you've got to kind of see what's actually buildable and ship it to market to get relevant feedback. So yeah, we've had to do a bit of both, but definitely there's been a lot of crypto research and new cryptography published from the Aztec side of things.
And circling back to the sort of hardware versus ZK proofs and ZK technology, where do you stand on that? Because like a question that that I think gets tossed around a bit is planning on sort of ensuring the long-term scalability of things or of blockchains, while also, yeah, ensuring privacy, sustainability, and a lot of ZK, yeah, technology is scaling vertically, so it's very hardware dependent. There's, yeah, controversial subject in the crypto space sometimes is energy intensive technology. So where do you stand on that conversation, and what is Aztec doing to either, I don't know if push one side forward or keep the balance in place in those conversations?
Yeah, I think a lot of the pushback currently for ZK tech comes from people trying to prove the Ethereum virtual machine, and there's no privacy in doing that. There's some kind of overzealous usage of the word ZK. Really, they're using verifiable compute to kind of prove the correct execution of an EVM block, and the EVM is not optimized for kind of efficient proving in any form of ZK proving system. So it can be very resource intensive. The goal is that will come down over time, and still having one person execute and prove is still better than the million Ethereum nodes that have to execute. So it's a step in the right direction. But for Aztec, because we're not using the EVM, we've built an execution environment from scratch that's optimized for privacy. Like proving the blocks is kind of it's not the main issue. Like we're optimized for kind of proving on phones and consumer devices. So we've already had to make a lot of advancements and trade-offs in the proving system to make sure that a user's kind of proofs can run in seconds on a phone. And so it's just a very different trade-off space. So yeah, I don't think the energy side of it maybe is a good argument. In terms of like how these technologies can link together, I think they're very compatible. They serve different uses really in my head. So kind of in the TE use case, it's kind of, I think it's good for kind of like short-lived privacy. So kind of stuff where like you need privacy for maybe 5 minutes to perform kind of a sensitive order book kind of algorithm, but actually post fact you don't actually mind if that's been revealed. You just wanted maybe the auction to be private. Whereas something like Aztec and kind of on-chain privacy is kind of more useful is when you want kind of long-lived privacy on-chain and you want to kind of commit to private state on-chain and have a blockchain kind of attest to the record of those events. So yeah, I think they're very compatible. I think we're actually exploring trying to get Aztec proofs generated inside a TE as like a way to kind of combine the two. So it's, yeah, I think pretty interesting horizon there.
I'd really want to use that software. Could I ask what on Aztec, what do you think are the most compelling applications that especially rely on the privacy to work as opposed to the patching and other non-strictly privacy features?
Yeah, I think there's probably 2 or 3 categories that spring to mind. The simplest is kind of just gaming. Like imagine we're going to play a game of poker, and I can see the flop, or I can see your hands, the cards in your hand. It's a lot less fun when you know the outcome. And so that doesn't need kind of like full on-chain privacy, but there's definitely some hidden information mechanics that are needed. And so this whole idea around kind of gaming is a vertical we're pushing quite hard. And then the second one is, I think, one that was mentioned earlier, just identity. Like everyone, I think 190 countries are signed up to the e-passport kind of doctrine, where passports have like an NFC chip in them, and there's a signature in those passports from kind of an issuing authority who's basically the government of your country. And we're seeing kind of some really cool use cases where you can prove you're a member, you have a passport from a particular country, you can prove that you're above a certain age, and that information is kind of attested to by like a state actor, and you don't have to reveal anything about your identity and share it with a third party in the process. So you're kind of able to prove that client side on your phone and selectively disclose just as much information as you need to enter some application or service. So those are kind of the 2 most exciting ones that are close to my heart. But yeah, I'm sure the design space is going to kind of explode as we see more developers playing with this. I think that the wrong way to look at this is look at the EVM and public blockchains and say, how do we add privacy to that application? Because by definition, the developers were kind of almost like a selection bias. They were building something in an environment where privacy was non-existent. So it's the wrong type of application. So as we see people have more access to programmable privacy, I think there'll be an explosion in kind of more interesting use cases than we can think of today. But yeah, that's the tip of the iceberg, I hope.
I'm going to ask this. This is a sort of open question to the panel, whoever wants to take it. But we talk a lot, we've spoken a little bit here about identity or, having something that's not regulatory enforced, but rather bottoms up. And I'm not sure how that happens, because at the end of the day, if we're talking a lot about how, and I want to gear this specifically for the question on identity, because identity is something that's very interlinked with governments, regulators, authorities. I think that's one of the biggest sort of concerns, that there's a lot of people who in fact don't have access to quote unquote government approved identity. And to do so in a private way, to do so just as like give people identity is already a hard problem, but then to do it in a private manner that respects, whether they have health issues or their age or any sort of political inclinations or all these sort of cascading effects. How do we match that up? How do we create that sort of bottoms up approach if we want it, and make it sort of aligned with a regulatory enforcement that might be aligned with private facing or consumer facing applications, cryptographic protocols, what users or what people who today are quote unquote unidentified might actually desire? I know that's a lot of that's a big way to ask the question, and you can branch off in whichever way you want. But yeah, I'm interested in that sort of balance between top down and bottoms up for something that's very closely in the middle, like identity.
Maybe I can get us started on this one. So I think one thing that we maybe haven't talked about quite in as many words is sort of the distinction between secure computing and like zero knowledge proofs, things like that for privacy. Zero knowledge proofs, you need to know all of the data in order to generate the proof, even if it's zero knowledge, a proof system, which means that technically there's not exactly privacy if some party is storing the data that is not the person who owns the data, right? And part of like what you want to do, like people who are already disenfranchised and don't likely have government identities, you don't want to expect them to do further work to like store their ID data and all of that. So then that brings us to a more general secure computation realm, which is lots of users have lots of inputs. How can you store them in a way that no party that, for example, is responsible for providing some of the compute power for this type of system, or some sort of overly snoopy parties are able to access it, and that then points to multi-party computation or trusted execution environments as the solution. So zero knowledge would be like straight up not the solution for storage of this type of identity. Is maybe one thing that I would like to point out here.
I don't know if I fully agree, because I think like in your example, like you're kind of assuming that the data had to go to a third party to produce the proof. But if the data never leaves my possession and it's my data, it feels like the best of both worlds. It doesn't apply to all use cases.
Yeah,
but
of course.
I think like there's a distinction between like a user making a proof and like a third party making a proof, and that's where I see the distinction between kind of useful zero knowledge proof systems and maybe verifiable compute if someone else is doing it for you. I mean, maybe to kind of add my 2 cents to the question, I think if someone doesn't have any form of like recognizable ID, I think a good thing that these kind of Web3 systems can do is help them build something up in layers. And so they may not have a full ID, but they may have a social media, or they may have an account with an email provider. Maybe they have like a single-use debit card that's like only lets them spend below a certain threshold because they don't have KYC. There's all these things that they can kind of add in to like an aggregate kind of ID scheme, and you don't know that this is kind of Joe Andrews, but you know that this is potentially one person, and so you can start to get like maybe like a lower level of proof of personhood before you have to start scanning eyeballs or anything else, just by aggregating kind of different IDs.
Yeah.
So
Yeah,
I'd love
I
to go
mean,
over this again. I mean, I mostly followed that, but if we go into weeds on one topic, I mean, this was pretty important. So, I mean, what I heard was two different views about how a TLS notary kind of application would work. I mean, I get the appeal of trying to stick to user-generated proofs as opposed to some intermediary, but isn't the point that that's somehow something that even with you need more things to change? Like, it's hard to make that right backward compatible because just TLS, for example, you get a vacuous guarantee if you just make a zero knowledge proof about the transcript you saw, because you can't fundamentally spoof that transcript client side.
yeah, so for TLS today, like you need a trusted intermediary to kind of also sign the data, and you're trusting the notary in that example. I think there are some pretty interesting kind of modifications to the HTTP standards, though, which have authenticated signatures. And so as soon as you have that, you like, I think it's gone from draft to standards track in February. I can't remember what the RC number is, but as soon as you get some kind of changes to the HTTP standards, you can just make a proof, and you have enough information in the kind of HTTP payload. I think ZK email is a good example of this working well, where you don't need the intermediary. In every kind of email, there's a signature that's signed by the kind of, at least the sending email service, and so you can prove certain things about emails in your inbox, and there you can just make a client-side proof, and you get those guarantees. Yeah, maybe earlier TLS was a bad example because it's not quite there yet, but people are kind of pushing it anyway because for some applications the security properties are sufficient.
Yeah, it's interesting. I mean, that's the example of industry then meeting, the security research community where they are in a way. And I guess it does leave us with a little bit of a dilemma right now, just because I hear you saying maybe don't allocate everything towards trying to fix this backward compatibility with TLS because the shift is coming imminently. And yet at the same time, it could still be done. Just that's one example that requires these other techniques. Yeah.
Yeah, I'm not sure what imminent is in a standards body, but I think it took years to get to this point. So my view is that going from draft to standards is as imminent as we can get, but it could be another 15 years. So depending on the variants there, we may have to wait a bit longer. I'll try and find the standard right now. Maybe some people in the audience, if they're in the standards body, could push it along for us.
By the
Jasmine,
way,
do you have a response you want to make on the? I'm sorry to cut you off a second time
Right.
now, but I'm interested if you have a response on the, what it takes to make it realized identity benefits in the sense of compatibility with expectations from regulators or authorities of any kind.
Yeah. Let's come to that in a second. I do want to say, Joe, that I don't think you and I are in disagreement. I do agree it's best if users can store things and users can do stuff with, say, a private key that they can associate with some sort of long-lived data on their device. What I'm trying to say is key management is a hard problem, I guess. It's maybe the TLDR, and that's where the like secure computation things come in. The second place, I guess, where secure computation does play a role is the compliance question that Andrew is asking. And actually, we did work on Candid, which is a decentralized identity system with, it basically focuses, among other things, on ensuring compliance with AML, KYC regulations that require basically screening for anyone who's on a particular sort of do not include them kind of list. And this in the US this is called the OFAC list. And actually we have a prototype that goes with that paper. I mean, it's relatively simple, but the whole point of the paper was to show that it can be done, that these things are not in conflict. You can prove that you're not on this type of list. You can prove that, for example, somebody who is on a list of approved users is not getting added to the lists, things like that. So yeah, I think all of these tools essentially in Candid, for instance, come together to show various facets of the problem. One other thing,
That's-
I guess, go ahead.
That's super cool. Yeah, that's super cool.
Yeah, I guess one other thing. So we did also, as part of that paper / a paper that we wrote before that with Ari Jules and some of the students from that group at the time. It's called DECO. I don't know if you guys have heard of that. That's basically zero knowledge proofs for TLS transcripts, where some party sits in the middle and makes sure that you are legitimately having a transcript. And they don't actually need to be anybody who like assures things, or they don't have to be an authority per se. They can be an authority for a particular application. And as long as a TLS session is going on, they can help basically approve somebody for some sort of application based on email accounts and things like that. And I think the big problem, by the way, there is also programmability and like efficiency of various things. By the way, this is like part of what we're using DYOR for, is like, can you make certain parts of this sort of TLS interaction really easily decipherable, and like, can you actually make statements about the contents of the TLS session in a way that's easy to program?
Where does fully homomorphic encryption come into play in all this?
Comes into play when I leave my watch at home and grow old.
I can add to that. I mean, I think like FHE kind of sounds like have your cake and eat it, but at least in the Ethereum space, it's I think it's a bit of a kind of like false dichotomy, because like we're trying to scale throughput of Ethereum, but with all of these kind of L2s and maybe add different features, and like in my head, like the wrong way to scale is by taking like an FHE computation, which is like at least 100 orders of magnitude. It's 100 times, not orders of magnitude, more computationally intensive. Maybe it's 1,000. I'm not sure what the current benchmark is, but taking that computation and asking every single node of a network to perform it is going to result in either a very centralized network or a very slow network. And so, like, I don't think it's a good solution to adding scaling and privacy to something like Ethereum. I do think that it can help with like some specific applications. Like if you can have an FHE server that's not doing kind of the EVM, which is a very uncomputationally friendly kind of VM, you maybe can have like some more optimized primitives for your application. Maybe you can kind of again use these technologies together to get the desired outcome. So you could have kind of some things running in with FHE, some things running with ZK, and you can assemble them to get the best of both worlds. But I think, yeah, at the moment the narrative is maybe running ahead of where the tech is, and we maybe need to rein it in a little bit, because it's still kind of maybe closer to research.
I mean, I have a short rant about FHE that's consistent with all of that. You mainly spoke about the downside of FHE because of its performance. My bigger concern with FHE, which isn't a reason not to use it, but you need to understand this whole design space, not just FHE. Even with FHE, which basically, maybe I'll backtrack, right? So FHE says you can have a public key system where you can encrypt some sensitive data to a public key, and untrusted workers can compute an encrypted function of that encrypted data, and you get the encryption of the function on the data. So then you can decrypt just the output of the function without having to see the intermediate values. Someone has to hold the decryption key. And so really the way the proposal works is that it's a lot like multi-party computation, where you have some threshold polynomial systems. So you have, say, 3 out of 5, have to be trusted for your integrity and privacy guarantees of this. So you'd say they hold, a multi-party computation. You could have those 3 or 5 nodes, do the work, but it would be really expensive in bandwidth because they have to do all these round trips of communication with each other. What FHE offers is that you could make it really communication cheap because you can outsource the work of computing on the encrypted data. These K of N nodes just have to be involved in decrypting the final output. And so it's a little bit of judo or a trade-off because you're shifting less work by trusted parties into more work, but it's to outsource to untrusted parties you don't have to care much about. And that could be really appealing compared to MPC. The thing that I think is most important to note, and it's a reason why even in a future where we use FHE, you'd also want trusted hardware in conjunction with that, is you're still trusting those K of N parties to decrypt just the result and only the result. And the problem with the FHE schemes understood today is that the key that lets you decrypt the result also lets you decrypt the original inputs and the intermediate results. And one of the best ways of getting around this problem is with trusted hardware working in concert with that K of N switch. So it's not a matter of if it gets fast enough, FHE will replace trusted hardware. It's that if it can get fast enough relative to non-FHE best MPC, then it could work in conjunction with trusted hardware for an ideal system.
Do you think that trusted hardware is then always going to be a part of the ecosystem, or do you think that there's some moment in time where we make them, whether, I don't know if obsolete is the word, but where they aren't really that important of a piece, or somewhere where they just don't necessarily,
Yeah, that's a great question, but I'm pretty confident that the answer is that trusted hardware will continue to be relevant. There won't be some sense in which the cryptography just completely gets rid of the need for trusted hardware. I think that's pretty meaningful long-term limit. In other words, one of the ways to arrive at this as a cryptographer is to consider some hypothetical world in which some of the things that we consider slightly out of reach objects in cryptography are available. There's this breakdown. I'm not a theoretical cryptographer, so I get this wrong, but there's like Cryptopia, mini-crypt. These correspond to different levels of assumptions of how much cryptography works in there. One of the interesting thought experiments is even indistinguishability obfuscation, which is up there at the very top of, if all the cryptographers' dreams are true, then we can have that. At the moment, that's considered even slower than FHE. Like that's to FHE what FHE is to the rest of the world of applied cryptography. So even in performance, it's out there, as well as less understood whether it's justifiable that it exists. Even in a world with that, there's still things that you can only do with trusted hardware and not that, such as essentially one-time programs or the ability to take one choice and prove that you couldn't have also simulated taking the other choice. Maybe that's a little bit abstract, but it's how I'd start answering this question, why I think that trusted hardware will continue to be relevant even as cryptography continues to improve.
Yeah, I fully agree. I think like on kind of like the need for trusted hardware, like it doesn't have to just be kind of like an Intel SGX or kind of like a computer trusted in the cloud. Like we've got like secure enclaves in phones, we've got like in all sorts of devices, and yeah, to my point earlier about meeting kind of industry where it is, like we haven't been able to use those secure enclaves because the cryptography's been too slow on some blockchains. But now we're kind of getting to a point where my hardware wallet can be my phone, can be secured by Face ID or the Android equivalent. So I actually see them kind of being used a lot more for the custody side of things, and then also on the AI side of things. Like I think NVIDIA are kind of looking at some kind of GPU trusted hardwares at the moment because they don't want to expose kind of sensitive training data to all these like billions of GPUs being trained right now. And on the other point Andrew made about kind of like almost like a time travel of like getting access to future cryptography today, I think yeah, if you have like a ZK proof that you want to make on your phone, but you're not quite there yet because the proving system is 2 years into the future, like you can look at two trade-offs where kind of you could just send it to a server and send them all your data and they can make the proof for you, or you could send it to kind of like a piece of trusted hardware. And yes, there's a chance that it's hacked in flight, but you kind of have some pretty good assumptions for that in the short to medium term whilst you're waiting for these new advances. And so it's probably going to be back and forth like that as people and developers start doing more and more advanced things. You're going to always need these kind of secure kind of enclaves or trusted hardware to execute things for you.
Do you think we'll be able to run the NOR prover on the enclaves on our phones?
Not on the enclaves on our phones today, but you can definitely use it to kind of sign messages. So I think it's the P256 curve, and so you can prove in a NOR proof a signature from the enclave, but you can't run the proof inside it. But if you trust Apple, which I guess you are if you're trusting their TE, then running it on your device is probably good enough if the key's inside the secure enclave. So yeah, we had people who've already built kind of secure enclave based signature schemes in Noir and in Aztec. So I think that's going to be like a big unlock for mainstream adoption.
Jasleen, do you want to file any NOR issues via podcast?
I think I can do it on Discord. Also, because I prodded for this at the beginning to see how much Joe is involved with this, and it seems like he's not the right person to ask.
I could run it internally to the right people, but yeah, what's how bad are the issues? Because we've made a lot of improvements recently to kind of unlock much more efficient computation. So yeah, if we want to get technical, we could try, and if not, I'll just say no comment.
No. I think they're not bad at all. I think it's mostly things that you're still working on, and it takes time to dev.
Yeah.
Yeah.
You can even just reflect at a high level on our experience in using NOR, because I've certainly been enjoying it.
Awesome,
Yeah.
that's great to hear.
Yeah. I actually have been using the new like breakdown of the back end and front end stuff. It wasn't easily accessible in the dev doc, so a lot of it took trying and fighting with Noir backend stuff. But I think it's
Is this
working
the flame graph?
No. This is just like literally writing like separate backend and having the backend even like put out numbers that are more detailed. I also try to change the backend to not to like read prover keys and stuff, which by the way, I guess is like eventually what you want to do with any prover. But that part I couldn't get working because of type system issues, things like that. So totally not my fault. I'm a great programmer. This is only type system issues that are not my problem.
I'm really stoked about the NOR using the recursive proofs feature with NOR. So I know Jasleen's I've seen the debugging that we've had to do to get that all to work, but having gotten it to work, it's still a really cool thing to be able to play with. That's been kind of in the zeitgeist, for a long time since the LibSnark gadgets, but now actually we've seen it work, and it's kind of fun to play with. And it's also been a lot of fun making data structures and algorithm implementations and more. It's been fun to,
yeah, the new proving system cuts down recursion a lot there. So I think you're probably still stuck with the ultra proving system, which is 30+ seconds in WASM to do a recursive proof, but the new one is kind of much less than that. So it's coming soon.
Oh,
so
exciting.
Yeah, if you want to go even more into kind of the dev branch, then I encourage you to try that one. But it's very kind of use at your own risk at the moment. Yeah.
I think that's all of academic work. So.
We're heading into the last 5 minutes of the panel, which has been deep into some of the weeds of what's going on across the encryption environment. And yeah, I'd love to sort of get back above water for some of the people who might not be completely down in the trenches like you guys are. and sort of take it back to sort of, so I've got two questions I'd like to end on, but I'll start off with one, which is something that you touched on, Joe, which is this whole idea of scaling through layer 1, layer 2s, and how maybe, is that the best way to achieve privacy, and should we still be trying to achieve some degree of privacy on chain?
Yeah, that's a tough question. So I think that, yeah, kind of, I'm going to assume by layer 2 you kind of mean linked to Ethereum, because that's where most of them are at the moment. I think it's there's a few reasons you want to build a layer 2, and in our head it's because you have access to one of the largest pools of kind of liquidity and capital that you can bridge trustlessly to kind of the layer 2 chain. Like if you build your scaling solution or your privacy solution as an L1, you have some trust assumptions to bridge to that chain, unless you can build like a full proof of each other's consensus on each chain, which is very complex. You have some trust assumptions to bridge funds between it. So one of the main reasons that people are trying to scale via L2s is because you have access to all of Ethereum's liquidity, which is, there's a lot of liquidity on Ethereum. And the second is just, yeah, the developer pool is very large of Ethereum developers compared to these other chains. So I think for those reasons, it is the best, but it doesn't mean it's the easiest. Like it's a lot easier to, well, not easier, but it's simpler to go and build an L1 that has privacy, because you can change how consensus works, you can change the cryptographic primitives you have available, and so you can kind of you can make things easier for you as a kind of a developer trying to add privacy. But I think you're kind of faced with this kind of problem of like, can you get liquidity? Can you get developers? Like, are people going to care about this? And for me, it's the wrong trade-off, because I really think you need to you need to start with kind of the user adoption, and kind of that's where things come from. So yeah, long way of saying, yeah, I think it's probably the best way of doing it. It's just there's a lot to build.
Yeah, I can imagine. Andrew, would you agree with that with Joe, or is there anything that you might be seeing that can be done on layer 1, or that is happening on Ethereum's layer 1 that we're sort of overlooking?
Yeah, it's tough. I mean, I think so much credible momentum and legitimate, broad and deep ecosystem has formed around these transparent smart contract blockchains. And so, that has to be respected and plays a big part of it. It's too useful to just say, well, we need to switch to a world where you just don't have that available because everything is private and that's the only thing that's there. At the same time, it's one thing to provide privacy app by app as something you just try to encourage because it's a good thing, versus something that delivers privacy as its a core thing and actually delivers value to people and perceived and realized value by using the privacy. That can be a way to get a beachhead into these. But it's tough because you really want it to be the default and the easiest way to do things and pervasive. And yeah, I guess that's the challenge. You can kind of impose it at a top level, like a platform that pretty much builds privacy right in, or you can leave it for individual users and app developers to discover on its own. I feel like I can see what this space is, but don't have really any clue what the right solution to select among those is.
Yeah, I can add a contrarian maybe thought as well, that I think there's actually a much bigger universe of kind of maybe zero-knowledge proofs or privacy apps that don't need to be on chain, but we can add a lot of this new cryptography and kind of fix some of the data leakage in the Web 2 world. And so, yeah, I think I'm excited about both, and especially kind of like for the DYOR ecosystem, because I can create a proof of some information and I can give it to Andrew, and I don't have to share that information with him anymore. And so there's lots of kind of like peer-to-peer or kind of like NFM kind of like models where you don't need distributed consensus and you don't need kind of like the full power of Ethereum to kind of actually settle those transactions. So I would encourage kind of people listening, if they're developers, to think about which applications need to be on chain because you need global distributed consensus, and which applications just need kind of the benefits of this new technology, and there's a big difference, I think. So yeah, you only need consensus in some applications, not all.
Jasleen, I'll toss the last question at you, which is sort of which is tying both of those ideas together, which is this idea of sort of, does privacy match up with an open and transparent system? Would you agree that it does align, or case dependent, or yeah, for specific use cases?
Yeah, well, I mean, this brings us back to the conversation that we had earlier about transparency, right? Transparency and openness do not have to mean everything is visible to everyone. I mean, think about government transparency. Often that means leave a paper trail for everything, so that basically there's pretty high disincentive to do malicious things or to do bad things. And so in that sense, I think they are not in conflict at all if you are to start thinking about transparency in this particular way of leaving a paper trail, making sure there's disincentive for organizations and places of power to shortchange individual users, for instance. But at the same time, not everything needs to be known by everyone. It just needs to be checkable.
Yeah, we think about transparency for the application, but privacy for the user. So like you can get a guarantee that you from the blockchain that a program has been executed as it was intended, no one's tampered with it. But you can still have the inputs to that program be private, and even the fact that you're running that program be private. So I think that there's kind of, as you just said, like that there's a few reasons why we had transparency before or accountability, and it's usually in the Web2 ecosystem to check that someone hasn't misbehaved. But if we're running it on a blockchain, that kind of goes away, and if we trust the code. So I think we can have the best of both worlds is my take.
Awesome. Well, we came up on time. I'm sure that we could have kept on jamming on this stuff for a while. Joe, Jasleen, and Andrew, thank you so much for taking the time. Thousands of viewers, thank you so much for taking the time. And the conversation was really enlightening. And remember to always do your own research. So have a good one.
Thank you. Thanks so much for having us.
Yeah.